Hello everyone, welcome to our presentation. The topic of our presentation is Reverse DNS Lookup. Our team members are Adishya Acharya, Simran Mohat, Yurul Pokhrel, Sunena Regmi and Srila Sapkota. Next. Have you ever wondered how you access web pages that you do every day? It's where DNS comes into play. DNS stands for Domain Name System. It was developed in order to bridge the communication gap between humans and computers. In the world of networking, computers don't go by names, but they go by numbers. It was developed in order to resolve name into numbers, that is, resolve domain name into IP address. Suppose we're looking for a website. For that, we go to a web browser and type in the domain name there. The other way also could be by typing IP address and retrieving the website. But as we humans are not accustomed to working with numbers, especially when millions of websites are present, it is not possible to memorize the IP address for all those websites. Next. Now, how DNS works. In order to understand the reverse DNS lookup, we need to first understand the DNS lookup. When we give query to a web browser, it searches for the IP address of the query in its own cache memory. If it doesn't find it there, it passes the query to the resolver server, also known as ISP. ISP also searches for the IP address in its own cache memory. If this also doesn't find the IP address there, the resolver server gets directed to the root server. There are 13 different sets of root servers. It doesn't know what the IP address is, but it will direct the resolver to TLD, also known as top level domain. TLD is responsible for storing the address of top level domain names such as .com, .net, .org, etc. Then the resolver gets directed to the authoritative name server. Finally, the server will return the IP address of the domain name that has been entered by the client. For example, yahoo.com has been entered by the user. The authoritative name server will respond with the IP address of yahoo.com to the computer, and our computer can retrieve the website through the IP address. Once the resolver receives the IP address, it will store it in its cache memory. In case it receives the same query again, it doesn't have to go through all the steps all over again. Now, moving on to the differences. Next. Talking about the difference between DNS lookup and our DNS lookup, that is reverse DNS lookup, as shown in the picture, we can see if a client is asking for the IP address of the domain name that he or she knows, then that is what we're referring to as forward DNS. But if a client asks for the domain name of given IP address, then that is what we're referring to reverse DNS. Now I would like to call upon my fellow teammate to take over the platform.
Next, as Srila have already mentioned the difference between forward and reverse DNS lookup, I will give you a brief outlook of what is reverse DNS lookup and how does it works. So, reverse DNS is a querying technique of the domain name system to determine the domain name associated with the IP address. It is exact opposite of forward DNS lookup. Next. So let's see how it works. Usually, PTR record, or also known as pointer record, is used to perform reverse DNS lookup. While DNS records are stored under the given domain name, DNS PTR records are stored under the IP address with addition of in-address.arpa, where .arpa is a domain mostly used for managing network infrastructure, and it was the first top-level domain name defined for the internet. In hyphen address.arpa is the namespace within .arpa for reverse DNS lookups in IP version 4, and IP6.arpa is the namespace for the IP version 6. Now let's dive into how we can do reverse DNS lookup. There are two methods, which are using Computer Console and online tools method. Next. If you want to perform reverse DNS in Windows, you can run nslookup with your IP address to check PTR record using command prompt. As you can see in the figure, we have given our IP address with command nslookup, and it has returned us the dns.google hostname. Next. Whereas there are two methods for Linux. Firstly, using digx IP address command, and you can see the output as shown in the screen where the domain name is provided. Next, secondly, host command is used to perform reverse DNS and you can get the domain name in a single line. Another point is using online tools. You can use MC Toolbox website to find the domain name in associated IP address. Now I'd like to turn over to my fellow teammates.
So, have you ever wondered what was the system like before DNS and reverse DNS came into play? So, there were actually two major approaches. One was host file, and the next one was network information system. So, talking about the host file was a plain text file that was stored on individual computers and contained a list of domain names and their associated IP address. When a network request was made from a computer, the operating system would console the host file first to see if there was a matching entry for the requested domain name. Uh, if there was a match, the IP address associated with the domain name would be used to make the network request. Though the host file provided a simple and effective way to map domain names to IP addresses without the need for a centralized system like DNS, however, it had several limitations and it could not scale well for larger networks because it was manually updated. It could become out of date or contain errors if the system administrator did not keep it up to date. Also, it could not provide the same level of flexibility and functionality as a centralized DNS system. And talking about the second approach, which was in practice, so that was a network information system. So, network information system was a distributed database system that was developed by Sun Microsystem. It was designed to provide a centralized location for managing network resources, including host names and IP addresses in a distributed computing environment. NIS work by storing network information in a central database, which can be accessed by client to resolve domain names to IP addresses. When we compare the host file with the network information system, NIS seems to be greatly efficient. As it allows for centralized management of a network information, making it easier to manage network resources across a large number of machines instead of having to make necessary updates on individual computers, which is quite time consuming and error prone. Though NIS worked better than a host file system, but still, it was not effective enough, which led to the development of a reverse DNS lookup, which definitely influenced the real world application. So, let's move to the real world application. So, talking about the real world application of a reverse DNS lookup, there are email authentication, content filtering, network troubleshooting, and a geolocation. Um, as I've already mentioned that email verification is quite influenced by reverse DNS lookup. Let's see how it works. When an email is sent, the recipient mail server performs a reverse DNS lookup on the IP address of the sender mail server. The recipient mail server queries the DNS for the PTR record associated with the IP address, which contains the domain name of the sender mail server. If the domain name in the email address matches the domain name in the PTR record, the email is considered to be valid and is accepted for delivery. Otherwise, the email may be rejected or flagged as a spam. In conclusion, we can say that email verification by reverse DNS helps to prevent spam and fraudulent emails as it ensures that the sender's mail server is associated with a valid domain name. So, talking about geolocation using reverse DNS lookup, it involves the process of determining the physical location of an IP address by looking up the associated domain name in DNS, which serve as a great tool to address the user of a particular geographic location. For example, if a website or online service is able to determine that a user is located in a specific region or a country, it can display content or advertising that is tailored to that location, like displaying prices in the local currency, providing information about local events or attractions, or showing advertisement for products or services that are popular in that particular region, so that the user will find that website more relatable and visit it again and again, and that ultimately helps to boost the business. After saying all this, I would like to ask my friend Ural to talk further more on the topic.
Good afternoon, everyone. I'll be further expanding upon the real-life uses of reverse DNS lookups in the other fields where they are used. Big techno giants and corporations also use reverse DNS lookups to understand which demographic they are reaching and which audience are currently viewing or using their medium. They achieve this by performing reverse DNS search onto all incoming traffic IPs and finding out loc which locations are they coming from, which domain name they are coming from, and which ISP they are using, which can be again uh, further investigated to find out the demography. This is also the technology which causes targeted apps to be possible in today's world, in which a user's browsing data is used to target ads to the audience of relevant measures. The other uses of reverse DNS is primarily first used in network troubleshooting. For example, in a network infrastructure, a client is not being able to assess a server. The network administrator can troubleshoot this problem by using reverse DNS lookup. While performing reverse DNS lookup on the IP of the server where the error is where the user is not being able to assess it, if uh, if no domain name is returned, we can find out that there is a DNS configuration issue, as in there is a error in the configuration of the DNS route of the main server. But if the reverse DNS lookup returns another domain instead of the intended domain, we can find out there's an issue in the DNS server itself, and that has to be resolved. It can be also used to find out IP conflicts. For example, if two clients are using a similar same IP to try and browse the internet, they may not be able to do so since there is IP conflict, and this is also diagnosed and found out with the help of reverse DNS lookup. Another use of reverse DNS lookup is in network security fields, as in firewall configuration and network monitoring, which are similar, which may be different things but incorporate a similar methodology for doing their things. In a firewall configuration, the network admin can set up rules using reverse DNS lookup. For example, if there is a server in which teachers of university or organizations store their local exam papers and their course materials, a person can ensure that that server is secure by performing reverse DNS lookup on every incoming IP and only allowing access to the server if the domain name matches that of the organization. It also helps to filter incoming traffic access, as in if massive amount of requests to join the server is coming from a single domain name, it can be indicative of a DDoS attack, and thus those requests can be denied in order to prevent a flooding of the server and causing the server to overload and go down. It is also used in network monitoring to look for patterns in network traffic, which is uh, similar to knowing your demography, but it is also used for both incoming and outgoing traffic. If some servers are compromised in a network infrastructure and uh, they are trying to access malicious websites, this can also be prevented by figuring out where the request is coming from, who is issuing the request, and which thus further identifying where the compromise or breach has been found. Now to discuss about the harm of DNS lookup and other topics, I'd like to call upon Simran Math to further elaborate.
Thank you, Viral. So the given statement that you are seeing in the screen basically highlights about the risks of the privacy. The reverse DNS queries are commonly used for the legitimate purpose such as a network troubleshooting and the small filtering. However, many people are not aware that these queries can put their privacy at a risk. They can be used to track the individuals and the organization and reveal sensitive information such as users' location or the employer when combined with the other data like a website log and a social media profiles. Furthermore, the reverse DNS lookup can be used to track the users across the internet and reveal their browsing habit. A recent study suggests that the continued and automated changes to reverse DNS record through DHCP may reveal the client identifiers that can compromise the privacy. So it is very important to be aware of these risks and to implement the best practices to protect the personal data and the privacy. Next page. Okay, in the recent years, the DNS threat landscape has been evolving rapidly and becoming a major vector for a cyber attack. The cyber criminals and the hackers are using a DNS vulnerabilities to launch attack and exploit the network weakness. Some of the emerging DNS threat include the DNS cache poisoning, DNS tunneling, and the DNS hijacking. So, basically, the DNS cache poisoning involves the exploiting a DNS server vulnerabilities to redirect the traffic to malicious website or inject the malware into the legitimate ones. The DNS tunneling bypasses the firewalls and the security measures by embedding the malware or the data in the DNS queries and response, while the DNS hijacking takes control of the domain's DNS record to redirect the traffic to malicious website or the server. Since the beginning of the COVID-19 pandemic, several attack varieties have targeted the home router with the DNS hijacking. So basically what in a DNS hijacking, the attacker uses a DNS record for a legitimate domain to point a site under their control and install the malware on the user's device so that they can either spy on you or either like your device will be contain a virus or something like that. So to protect the network and the users from this threat, the organization need to implement the robust security measures. This includes deploying a DNS security protocols like DNSSEC, using a DNS firewalls and intrusion detection system, and implementing a VPNs. Regular monitoring of a DNS traffic for signs of malicious activity is also very crucial. Next page. Now let us see the potential development and future of a reverse DNS lookup. The future of the reverse DNS lookup is likely to be see increased use of the IPv6 and DNSSEC integration, as well as this since this is the era of the AI, the adoption of the AI-powered tools to improve the accuracy and automate the process of updating a PTR records. There may be also a focus on enhancing a privacy and the security measures pro- to protect the of updating a PTR records. There may be the focus of enhancing a privacy and a security measures to protect the user's data from the misuse. Additionally, the development of the new standard and the protocols could also provide the better ways to perform the reverse DNS lookup and the manage the PTR records. Those advancements will also be crucial in ensuring a continued usefulness of a reverse DNS lookup while mitigating the potential security and the privacy risks. So basically, in a conclusion, the reverse DNS lookup is a valuable tool for identifying the domain name associated with an IP address. However, it can be used for tracking the individuals and the organization, posing a threat to privacy and the security. The DNS threat landscape is constantly evolving, and organizations need to be aware of emerging threats such as DNS cache poisoning and the DNS hijacking. So basically, to mitigate this threat, the organization can implement the security measures like DNSSEC, DNS firewalls, and also regularly monitor the DNS traffic for signs of malicious activity. So saying this much, I want to conclude our presentation, and thank you everyone. Thank you.